My name is Adam Wathan. I'm not going to talk about myself at all because I don't have time because we've got too much cool stuff to go through. So, today I want to talk to you guys a little bit about what I think is sort of a fundamental misunderstanding that I held about object-oriented programming for a long time that I think made my code unnecessarily complex and less fun to work on. So I think the best way to talk about it is using a contrived, silly example. So, is this not going to work? Come on. Okay, I guess I'm using the keyboard to navigate here. All right, say we have this plant, right? This plant is desperately in need of watering. It's a dying plant. We got to save the dying plant, right? And say we're trying to do this in code. If I was trying to do this in code, the way that I would solve a problem like this is I would think to myself, okay, I need something to water this plant. What has the ability to water plants? And I would think on that for a little while and think on it, trying to model my domain in my head, and eventually a light bulb moment would happen. A gardener can water plants. This awesome gardener dude, he can help me out here. So how would I solve this problem in code? I would do something like, I'd new up a new gardener class that I created. I'd add a water method to the gardener because watering is something that the gardener can do to plants. And I would pass in the plant that I needed to water. And when all is said and done, we have this beautiful, healthy plant. It's not the same plant as was in the first picture. I apologize. I didn't plan this talk out with enough notice to sort of take a picture of my own dying plant. You know, anyways. So anyways, this is how I programmed for a long time. This is how I thought about design. I needed to do something. I would think, what can do that thing that I need to do? And I would come up with an object to do it. But then I started paying more and more attention to the APIs of just like really basic objects that exist in basic, like that come with the language, and noticed that they worked a little bit differently than how I thought about object-oriented programming. So for example, here's a JavaScript example. We have an array of names, and if I want to reverse that list, I call the reverse method on the array of names. Another example, a list of names as a string in JavaScript. I want to turn this into an array, sort of split this string using a certain delimiter. I call the split method on the string, pass in the delimiter, I get an array of names. Here's a PHP example. I have a date, and I want to format it so I can sort of display it in a human readable format. So today is Wednesday, we create a new date time, defaults to today. I format it using the L format string special character, and we get the day of the week, which is Wednesday. So, looking at this example again, the way that we talk about watering plants, I want to deconstruct this code and sort of translate it into an English sentence to talk a little bit about what the difference is here. So in this case, we're saying that by having a gardener object with a water method that takes a plant argument, the gardener can water a plant. So we have this general sentence structure of an object can method some parameters, right? Like it's acting on the parameters. The object is the thing that has the ability to do the method to the parameters. So let's slot in the other examples we looked at into the same sentence structure and see what happens. Okay, so names.reverse, an array can reverse. It's a little bit grammatically awkward, but it's not too bad. I guess I can live with it. What about this one? Names.split, a string can split a delimiter. What? Because it's a great GIF. The string isn't splitting the delimiter, right? It's not like the string is some sort of string splitter that you pass a string to it and it splits it. We're splitting the string. So what we're really saying here is that a string can be split using a delimiter. The method is something that's acting on the object, not something that the object can do to other things that you give to it. So when I noticed this, I realized that this general sentence structure, you know, that an object can be something using a parameter, was sort of treating methods as affordances on objects rather than abilities. So what's an affordance? So an affordance is like a property or feature of something in the world that tells you how it's meant to be used, or tells you things that you can do with it. So for example, a drawer has a handle on it, and that handle is an affordance telling you, like, this can be pulled. If that handle was there, it'd be hard to know how you're supposed to open that drawer. You might think you push it and it pops open or something, but the handle is there as an affordance to sort of signal to you, using its physical features, that this is how you are meant to use it. So applying this line of thinking to like objects, by saying that a method is an affordance, we're saying that methods on objects are the object's way of telling us what we can do with the object, not what the object can do to other things. It's subtle, but I think it's important. So if we take this same sentence structure and apply it to our other examples, we can see like a string can be split using a delimiter. That works perfectly for this API. An array can be reversed. Yeah, makes sense. A date can be formatted using a format string. And even more controversially, you know, a user can be saved. How many times, right? How many times have you heard that argument like, a user can't save itself, it's not a database saver thing, it's a user. But that's not what methods are. Like, that's a straw man argument. A method is just saying, like, this is something you can do with this object. And if the user represents a database record, well, being able to save or update or delete a database record, those are the only things I even really expect to be able to do with them. So it makes perfect sense to me. Let's jump back to our gardener for a second, this bro. So using this sentence structure, when we translate gardener, water, plant into English, we get a gardener can be watered using a plant. Maybe this makes sense if you're making like a Revenge of the Plants game or something like that. But you know, when I see this, I just think. So, it's not that a gardener can be watered using a plant, right? It's that a plant can be watered. The interesting thing here is that the gardener just disappeared. He's gone. So we don't need this code, right? Like the more object-oriented, purest way to write this would just be plant water. We're watering the plant. So anyways, this was a pretty important realization to me about how to model things in object orientation. So I want to go through a bunch of real-world examples from an application that I built recently to talk about some of the benefits of thinking this way and some of the problems that it's helped me solve. So, the very first problem that I think it solves is eliminating agent nouns. So agent nouns is a pretty cool term that I had never heard of before that I'm glad exists because it describes what I want to talk about perfectly. So an agent noun is a noun denoting someone or something that performs the action of a verb. So like driver is the agent noun for drive, or splitter is the agent noun for split, like we were talking about this contrived string splitter example sort of thing. So let's take a look at how we can sort of use this way of thinking to eliminate agent nouns from our code base. All right, so I think we're going to have to start by making this readable by literally anyone in the room, including me. So this application that we're looking at, for people who know me, you probably know that I create courses and stuff on the internet for people to learn programming stuff. So this is actually sort of simplified, modified code from my course platform. So I just kind of picked the most recent app I had worked on and went looking through it for examples. So everything here is super real world. Okay, so we're going to start with some before, then we're going to work towards some after. So agent nouns, here's an example. So one of the things that you can do in this app is broadcast an announcement to all of the users. Just send a message to everyone saying, hey, new lessons have been released, that sort of thing. So let's take a look at how this works. We create an announcement in a controller. Then we use the announcement broadcaster, right, because we need an object to do the broadcasting, and we tell it to broadcast the announcement. So this is thinking of methods as abilities, not as affordances. So what does it look like to rewrite this code, thinking of methods as affordances instead? Well, we're not trying to broadcast the announcement broadcaster. We're trying to broadcast the announcement. Is this font size okay for everyone? It's okay? All right. Well, I can bump it up a little bit if anyone has a problem with it. So anyways, if we want to rewrite this using this other style, we would just do something like announcement, broadcast, and we'd be done. So let's take a look at what that would look like to implement and talk about this a little bit more. So let's head over to the announcement broadcaster and grab the broadcast method here. and we'll move it over to the announcement eloquent model here. So broadcast no longer takes an announcement parameter, and announcement here, where we're trying to update the announcement saying like it's broadcast at timestamp is now because now it's been broadcast. Well, this just becomes this instead of announcement. So jumping back to the slides for just a second, because I think this is kind of interesting. By writing code this way, we're promoting encapsulation. So encapsulation is all about making sure that as few objects in the system as possible have access to other objects' internal fields, right? An object should sort of manage its own state and be responsible for its own fields. So in the previous example, the broadcaster was manipulating the announcement. It knew about sort of internal details of it. But in this case, by moving broadcast onto the announcement, well, now the announcement is updating itself, and knowledge about updating this column isn't actually leaking out into the outside world. So it's a little bit more encapsulated. Similarly, we can just pass this into the broadcast announcement job. So because this is sort of an expensive operation, we push it into a background job. It's got to go through all the users in the database, send a bunch of emails. But this part is a little trickier, right? This dispatcher, dispatch. How are we going to get the dispatcher to actually dispatch this queue job? If you look at our original example, this was injected through dependency injection as a constructor argument. So we can't inject it as a constructor dependency into the announcement because the announcement is just an eloquent model, right? We create the eloquent model just by passing through its fields. So we have a couple options. I'll talk about option number one first. The first option is basically to use a facade, right? Use service location. So we could do something like queue dispatch and just pull this in as a facade. And now we're sort of grabbing this from the container in sort of a global way. And I think this sort of thing used to really irk me. I used to see stuff like this and be like, oh, that's disgusting. Why would you ever do that? Oh my God, the purity of the code has been compromised. So I want to talk about that a little bit because I've started to sort of come around on it. So conquering your fear of facades. So you may not realize this, but in PHP, you depend on global state without, well, so let's start by saying the real reason that people don't like facades is because they feel like you're coupling yourself to the framework, you're depending on stuff that exists globally outside of the object, it's not being injected in, you're not listing out the dependencies explicitly, it's harder to know what it's doing, that sort of stuff. But the reality is you depend on global stuff in PHP more often than you realize, and there's good reasons for it. So here's the example that I like to use. Here we're creating a new datetime, specifying the America-Chicago time zone, formatting it to display it to the screen. We set it to a different time zone, format it again, and now the time zone has been updated and we see the correct date and time, right? I think everyone would probably agree that this is a pretty convenient and nice API for working with dates and changing time zones and stuff. But have you ever thought to yourself, like, how is this actually working? How are we able to convert between time zones by just newing up an object? Well, under the hood, this is basically globally accessing a time zone database that's installed on your system with PHP that you can update using PECL and stuff like that. But because of that, say in an application you wanted to be able to create one date time that used one time zone database and another date time that used a different time zone database, it's totally impossible to do that. Because it doesn't matter, because no one cares. No one needs to do that, right? But think about like what this API would have to look like if you did want to support that sort of flexibility. You need to have like a datetime factory that was constructed with a time zone database. You need to inject the datetime factory into any object that needed to create dates and use the factory to create dates, and you might need multiple factories that took in multiple time zone databases. That would be like a real pain in the ass. No one actually wants to do that because ergonomics are important, right? Like making something pleasant to work with and nice to work with is an important API design consideration. So reaching out and globally accessing the container is not really that different from that. If you just have one queue dispatcher in your system that's configured per environment, using different drivers and stuff, it's not actually that bad to just go out and grab it. The ergonomics of it might be worth the trade-off in flexibility. Now, that said, I'm probably not going to convince everyone, so let's talk about an alternative solution. So something that you might not know is that with functions in programming languages, they can actually take parameters. You can pass things into functions. For example, you could pass in a queue dispatcher, and then you could just call dispatch on the queue dispatcher. Now in the controller, instead of using this broadcaster, we would pass through a dispatcher, and instead of injecting the announcement broadcaster into the controller, well, maybe we just accept the dispatcher instead that we need to pass through. So now we're not coupled to the container. We still eliminated this agent noun, that being the announcement broadcaster, and everything works totally fine. Parameters, they are your friend. That said, personally, I would still write it this way. And even then, I would actually probably write this a little bit differently. You can actually do broadcast announcement dispatch. This is a recent-ish Laravel thing, I think Laravel 5.4 or 5.5, but you can just dispatch a job directly, which under the hood, it's still using service location and stuff, so you're still making that same trade-off, but it looks a little bit nicer. So this is probably how I would write this code, despite the fact that I'm more coupled to the container. All right, let's look at another example. So here's another example of an agent noun, same sort of thing. We're going to look at a product purchases controller. Let's clean this up a little bit so we can see this a little bit more clearly. All right, so this controller accepts this purchase fulfillment service, right? So when someone purchases a course, we do some stuff to charge them and create their purchase, but then we use the purchase fulfillment service to fulfill that purchase, create their course licenses, send them an email with information about their purchase, that sort of thing. So the thing about this purchase fulfillment service is that we all know that really this is just a purchase fulfiller, right? But everybody in this room knows that that's a stupid fucking class name. So what do? We throw a service on the end to make ourselves feel better about it and pretend that it's like a good idea, when really we're just like masquerading around this really stupid class as something else. So usually things ending in service are also these stupid doer classes, just kind of disguised. So how can we rewrite this treating methods as affordances? Well, we're trying to fulfill a purchase, right? So why don't we just fulfill the damn purchase? Purchase, fulfill, and then see what it would look like to fix that. So if we head over to the purchase fulfillment service, all right, so this takes a mailer, it creates some licenses, and then sends an email to that user. So why don't we go ahead and copy this method, paste it into the purchase class. We'll just throw it up top here. And now this just gets called fulfill instead of fulfill purchase. It doesn't take any arguments anymore. All references to purchase here just become this. So again, promoting encapsulation. But we do have to figure out this problem with the mailer, right? So same solution. We could just use the mail facade, right? That's one way to do it, mail to. We could accept the mailer as an argument. Or in cases like this, something that I like to do a lot of the time, when this is kind of just like side work that's not really critical path work, like the most important thing is creating licenses here. Sending this email to the user, you could think of it as just being like an ancillary piece of work. So in cases like that, a lot of the time I like to push side work to event listeners, which can help clean this stuff up a little bit and make you feel less guilty about doing all this work in a model if that's still something that's bothering you. So here I might just do something like purchase fulfilled, dispatch, and then pass through the purchase that we're fulfilling, cut this out, and then generate an event listener for it, right? So the main reason I wanted to talk about this event listener stuff is because I think a mistake that I see people make a lot with event listeners is they name them really silly things, like they might do artisan, make, listener, purchase, fulfilled listener. But this isn't a great way to name event listeners. A better way to name event listeners is after the action that they're actually going to perform in response to that event. So in this case, I might call this like send, purchase, fulfillment, email. And that would be the job of the listener. So the listener is almost named like a function, not like a noun, you know? So you could go ahead and make this listener, head over to the send, purchase, fulfillment, email listener, paste in this code here. And now we don't have to rely on the facade here, because this is resolved out of the container. We can inject the mailer. The event is going to contain the purchase, so we can say event, purchase, email, and then event, purchase, here. And now this is going to end up basically, working the exact same way. We're still depending on service location in the sense that this event dispatcher is being resolved out of the container. But if you really wanted to, you can also do something like static get event dispatcher, because eloquent models actually have a reference to the event dispatcher that's set up during the boot process of the framework. And here you could just call that method and then dispatch, a new purchase fulfilled event passing through the purchase. So that's another way that you could do that. But personally, I just stick to this approach. So again, the main takeaway there, name your event listeners like actions, not like nouns. So let's head back to the product purchases controller, delete this reference to the fulfillment service since we're not using it anymore, rip it out of there, rip it out of here, and we can go ahead and delete this class now, right? So we don't need it. So that's a way that we've simplified our code a little bit, removed the need for this object that didn't really deserve to exist because the method belonged on an object that we already have. All right, what do we got next? Breaking up God objects. This is kind of a fun one. So God objects are objects in your system that tend to attract a lot of behavior, objects that tend to have tons and tons of different methods on them. So one of the reasons that you end up with God objects in your system, I think, is because, like we've been talking about, you have a tendency to want to put methods on things that can do stuff. So user, for example, ends up being an object that ends up with a lot of methods, because a user is a person, which is a sentient being that can do stuff. So the user ends up having a lot of methods on it for doing things, because you think in your head, well, users can do stuff, but purchases can't. So let's take a look at an example of that in this particular app. So if we head over to license redemptions controller, so this is where a user can come and redeem their license for a product that they purchased and get access to the course. So here's the culprit that we're going to look at here. We have the user with a redeem license method, and then we pass through the license that we want to redeem. So because we're thinking of methods as abilities, we think, okay, well, who can redeem the license? Well, the user can redeem the license, so we put that method on the user and pass in the license. But if we think about methods as affordances, we're not really redeem licensing the user, because that doesn't make any sense. We're actually redeeming the license. So we could rewrite this code as just license redeem, pass in the arguments necessary for redeeming the license, which in this case is the user. And now we can actually move this method from the user. So redeem license can get moved from here over to the license class. And now the license class that didn't really have much of a purpose other than to be an eloquent model has some real behavior on it, right? So we redeem the license for the user. Instead of updating the license from outside, now we're updating it directly. So again, promoting encapsulation. This becomes user get key. And then here I'm just dispatching a license redeemed event for any ancillary work to listen to and act on the fact that this license was redeemed, like maybe giving that person access to a GitHub repository or stuff like that. So that's one example of how thinking this way can help you break up God objects, because it forces you to think about which objects methods actually belong on. Okay, let's look at another example. Uncovering new concepts. So this one's kind of fun. So like we talked about before, a lot of the time the thought process for writing new code is, what could do this? Let's create that thing. So far, all of our solutions have been adding methods to objects we already have, but you don't always have the object that you need to do the thing. But by thinking about things in an affordances mindset, you'll create different objects than you would have thinking in the abilities mindset. So let's take a look at an example of that. So we're going to head back to the product purchases controller again. Okay, so we got rid of the purchase fulfillment service, but we still have quite a bit of work here happening around actually charging the user, creating the purchase, fulfilling the purchase. I like to think of the anatomy of a controller action as kind of being 4 steps. There's fetching the data that you need, which in this case we're doing with route model binding. There's validating the request. There's doing the thing that the controller action is supposed to do, which is all these lines, and then there's sending back a response. So in this case, this step is maybe a little bit bigger than we might want. And you can see it getting even more complicated if we added coupon handling or a bunch of other more complex features around actually purchasing things. So if we're trying to extract this to an object, we have to think, what is the thing that we're doing? And then what is the thing that we're doing that to? And that is the object that we need to create. So looking through this, I might think on it for a while and think, okay, well, we're charging the person, we're creating a purchase, we're fulfilling the purchase. It's almost like what we're doing is the action is almost like completing the purchase. They've started the purchase by making the request. We want to kind of complete that purchase and send them back the finished purchase, right? So you might think that we could do something like purchase, complete, but we don't actually have a purchase yet. The purchase doesn't get created until after the purchase is already complete. So you have to start thinking about like other terms, like what are we actually completing? So I thought on this for a while, and the noun that I came up with was checkout. So what we've sort of done by sending in this request is initiated a checkout, right? We started a checkout process, and by completing the checkout, that's what's creating the purchase that we can send back to the user. So what does it look like to use that sort of metaphor? So let's just write it up here. So maybe we have like a checkout that we get by creating a new checkout and passing through whatever parameters a checkout would need, right? So we're checking out what's involved in that. We've got a bunch of things here. We've got a product, we've got a payment gateway that we're using to process payments, the user's email, so the person purchasing. So I think in this case, it kind of makes sense that the checkout would encapsulate the product that's being purchased and maybe the user that's purchasing it, so the email address of the person that's trying to make the purchase. So now we have this checkout. So now we can complete the checkout, right? So if we call checkout complete, we have to think, okay, well, what arguments should this take? Well, we could use service location to grab the payment gateway and maybe just pass in the payment token that they actually need to like finish the Stripe checkout. I think it's probably a good idea to pass in the payment gateway though, because I could see us eventually supporting multiple implementations. Like maybe we use this same thing for PayPal and for Stripe. So this should be polymorphic in some way. We should be able to pass in multiple. So that's a really good argument for doing this sort of method injection approach instead of using a container, right? So here's kind of our API. And I think when you complete a checkout, well, we need to return the purchase from the controller. So maybe here is where we get back that purchase. So let's implement this really quickly. I'm going to use artisan make model to create a checkout. Now, it's not actually going to be an eloquent model, but that's the fastest way to create classes from the command line. So I always just create them that way and then delete this stuff. There needs to be like an artisan make class. All right, so let's move some of this code over. Okay, so we're going to have a constructor. The constructor is going to take a product and an email. Email, not mail. Oh, what am I even doing here? Butterfingers. All right, so let's copy this code into that class. So we'll cut this out, and we're going to add a complete method here. And the complete method takes a payment gateway and a payment token. And we got an extra comma there. I see it. Don't worry about it. We're not running the code anyways, so it doesn't even matter. None of this stuff could even work. Who even knows? So this payment gateway is going to get replaced with just payment gateway. So we can get rid of this since we're no longer storing that as actual instance state. We'll spell payment token correctly. I know some of you saw that. So we'll change this to payment token. And then anywhere where we're referencing the product, well, that's going to become this product now, right? So we can update these three to be this product. Request email, that's going to become this email. And then after we fulfill the purchase, we can return the purchase. And here, we would basically be done. So we've sort of extracted this off to a new checkout object, which is just not the sort of object that you would have created if you were thinking in terms of like what object can do the checking out, right? So I think it's sort of interesting because it forced us to sort of discover this new thing in our system, which is kind of interesting. All right. We got one more example to get through. We started a little bit late, so I think I'm still good for time. So the last one, the last idea anyways, is that sometimes you just need a function. So what do I mean? Let's look at an example. Let's head over to the purchase class. So here in the purchase class, when we fulfill a purchase, we create some licenses. So if someone purchased 3 licenses for a course, this is going to generate those 3 licenses. And part of generating a license is creating a unique access code for that license, right? I know this isn't guaranteed to be unique. It's basically guaranteed to be unique. It's 32 characters long. All right, so let's take a look at a test that I wrote for this. So here we have like a really simplified test just to sort of highlight the part that I want to talk about here. So fulfilling a purchase, we create a purchase for a single license, we fulfill it, we make sure that it has one license, and we want to verify the license code. So this is where things get tricky. So a lot of the times in testing, you need to be able to stub things out so you can make assertions about what happens there. And with something like generating a random string, that's like non-deterministic really, right? We can't really predict what it's going to be. So of course, like this test is going to totally fail for a totally different reason, which is fine. It's because we didn't actually create the event. So if we just head over to the purchase fulfilled class for a sec, comment out that event so we can run the test. Okay, so you can see it fails because we were expecting ABC123 as our fake code, but we're getting blah, 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 right? So how could we test this? How can we like predict what this is going to be? And I think this sort of problem is what leads a lot of people to want to do things like, well, I guess we need a license code generator, right? So we have a license code generator. We resolve that out of the container, and we call the generate license code method on it. How many people have seen code like this or written code like this? I have, where you have like an object that only has one method that's just like a totally symmetrical version of the class name. That's a smell. All right, so I'll do this sort of thing just so I can stub out the license code generator in the container so I can stub out the return value so I can actually write this test. But the thing is, I don't actually want a license code generator, right? All I really want is a function for generating license codes. I don't actually need a whole class to do that. So what if I just like resolved like generate license code out of the container and then like invoked it? If I head over to the test, I could do something like, let's hope to God I do this all right, by the way. Instance, generate license code. We can bind in a closure there that just returns ABC123. And if we did this right, it's green. I'm so glad that actually worked. I didn't think to demo this concept until literally 15 minutes before I came on stage. So I was scrambling to write this test and never actually got to walk through it. Okay, so that's one way that we could do that, right? Like we don't actually need an object, we just need a function. But this can be kind of messy because now you have this function that's got this random string of a name. It feels like it's floating around in this sort of uncontained, unnamespaced area. So what you can do instead, that I like to do a lot of the time, is create these sort of invocable classes in PHP, which are really just there to act as like nicely namespaced functions. So let's take a look at what that would look like. So in the purchase test, instead of generate license code, we can do generate license code class. And again, this is just a function hidden in a class, right? And we're being explicit about that by using invoke to sort of make it work. Now here in the purchase, we can resolve generate license code class out of there. If we head over to the terminal, we can do artisan, make, model, of course, generate license code. And if we open the generate license code object here, we can get rid of this crap. Just add invoke, and this can just return what we had before, which was like stir random 32. Now if we make sure that we import this here and in the test, then if I did this right, it still passes. So what we're doing now is we're resolving an object out of the container, which is really just a function disguised as an object, but I feel better about it because at least we're being honest, right? We're saying this is named like a function, all you can do with it is invoke it, like it is a function, it's just represented as a class in PHP because that's the easiest way to give it a name and put it in a namespace. Okay, so something else that's kind of neat about this, just a little trick that I like to use to kind of make this code a little more ergonomic, is that a lot of time I'll create classes for this sort of thing to sort of hide this container access. So I might kind of cut this out and do something like license code generate. And then, of course, we're going to make a new Eloquent model here, which isn't actually an Eloquent model. And really, this is just like a class with a single static method called generate, and all this does is resolve that out of the container for us and invoke it. So, if we've done this correctly, fingers crossed, still passes. So now when we actually look at the purchase code, it's very expressive, right? Like we're generating a license code, and what happens there is we resolve this function out of the container so that we can override it with a different function in tests if we need to. But that's the only reason that we've really extracted this to a separate function, is to make make testing easier. So that's what I mean when I say like maybe you just need a function. Just bind a function to the container, whether it's just a closure under a name or an invocable class, and just kind of be honest with yourself. Like I'm not making a license code generator, like I know that is silly, but I do need a function for generating a license code because I need to swap that out sometimes for different stuff. So this can be like a good way to do that. So that's actually all I got. Those are all the examples that I wanted to walk through. But I do want to leave you guys with just like one final note, which is basically, I'm not trying to say that you should never, ever, 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 ever make a class that ends with ER or something, right? I think a lot of the time you do need to make classes like that, and they can be useful in certain situations. But what I am saying is, try not to reach for that as the first solution. I think historically, I've always thought like that's the only way to solve my problem. I have to make a class that can do this thing. So it's going to be some sort of noun verber class or whatever. But thinking this way has given me some more options that I can try when I'm trying to solve a problem before kind of resorting to that, which I sort of think of as a last resort measure at this point. So I hope that was an interesting presentation. I hope that helped you think about object orientation maybe a little bit differently than you have in the past. And enjoy the rest of Laracon. Thanks, everyone.